We can get started just a little bit early since we've run out of books. So a couple things. First, thank you all for coming. These talks are sometimes done on short notice, so I appreciate you all keeping up on your email. Thanks to Mike for doing the presentation. Thank you to Heike and the QA managers for supplying the books. Google put in an order for 150 of the books in order to get everybody thinking about web software and insecurity. For the talk today, Mike has agreed to have the talk videotaped, and we're going to put it up on Google Video externally. So questions are okay, but if you have any questions at the end that are of a confidential nature, just wait until we finish videotaping, and then you can ask questions. And at about noon or so, we lose this spot, and we're going to head over to lunch. So although it hasn't been done officially or anything, you're very welcome to join us for that. Okay, thanks very much. Mike Andrews.
Thanks a lot, Harry. Well, thanks for inviting us up here, and thanks, Harry, for the great quote on the front of the book. I'm sure it's, more than doubled the amount of readership of it and everything. So let me just introduce myself very quickly. I'm Mike Andrews. I'm a senior consultant at Foundstone, which is a professional services company. Mostly what we do is we do security testing and them kind of things. I lead up the web testing, so I lead up the application web services, valuations and that. And also I teach ultimate web hacking classes. So that's sort of my background. And before that, I was professor at a university, and before that, as you can tell by the accent, I was from the UK. So please don't hold that against me too much. As you guys are obviously aware by setting history here, we're living in a web utopia now. Pretty much everything's now becoming on the web. And if you look back in just its early history, November 1992, there were 23 web servers out there in the world. Everybody knew where they were. Everybody knew where to go and get their, their physics porn. So off they went to a particular server to get that. Today, April 2006, there's about 80 million host names out there when you look at the survey from a company called Netcraft. Now, I actually think that maybe that number's a little bit low, especially with, the number of pages that you guys index. Over 8 billion pages, it might be a little bit low. But this just goes to show, even if these figures isn't completely accurate, it just goes to show how much things are growing. So the growth of the internet, or the World Wide Web, the initial idea was, geeks sharing physics documents. And a little bit before that, it was effectively an online phone book. Whereas nowadays, you've got, 6.5 billion people on the World Wide Web, according to, internet statistics. Everything's on the web now, from the phone books and stuff like that to your email. Companies trading on the web. You've got companies that just solely exist on the web. They don't have any other kind of outlet. Amazon is a good one. They have no physical bookstores or anything like that, yet they ship physical goods. So, this kind of stuff has changed a lot over the years. And now what we've got is we've obviously got the next big push of that Web 2.0, which is a bit of an odd saying, the next generation of things, but, a good picture, it says 1,000 words and everything, that's one half of the picture. All these companies out here, you guys will probably recognize a few of them in there. There's Blogger in there, there's Rightly, there's Gmail. On the other page, there's a whole bunch more that you'll recognize. But you'll see that what's happening is more and more applications are going onto the web. It's not just information out there now. Everybody's actually using it as a delivery platform and as a way of pushing software, not just statically browsing pages and things like that. So obviously we're talking about security, and we're talking about, how to break web software and stuff like that. So what is the state of play out there? So what I did just before I come along, I went and had a look at 2 days worth of vulnerabilities from Security Focus. You guys must know this site. It's a pretty well-known website that basically, lists the vulnerabilities as they occur, and a place where you can track them and see what's going on. And just by scrolling down, you can see that there's a fair few web vulnerabilities and things like that. Another good place to go to see the kind of what's happening out there on the web in terms of security is the Web AppSec community and the vulnerabilities. Yeah, sorry guys, I can't scroll up any more than that, but you can see the kind of things that are going on all the time. So what is generally the state of play out there? So the state of play looks something like this. 45% of the of the vulnerabilities that I looked at over Monday and Tuesday were to do with the web in some way. In fact, the Monday and Tuesday statistics were a little bit skewed slightly because there was a fair few vulnerabilities that were released for Internet Explorer, which made the app portion, the app percentage go up. And also there are a good few vulnerabilities released for the Linux kernel, which pushes the OS up a little bit more. Now that's pretty uncommon in terms of the statistics. Whereas if you look at things like lib, which what I'm saying there is libraries, so things like network libraries and stuff like that, there's a lot less vulnerabilities being released and being notified on these day on day. Whereas if you go back just 10 years ago, the number of vulnerabilities that would have been on network stacks and stuff like that would be a huge proportion. Back a bit further, 5 years ago, it would be the OS vulnerabilities would be a lot bigger. Then it was application vulnerabilities were a lot bigger. And now you'll see that web vulnerabilities are taking up more and more of a slice of the pie. So what are these vulnerabilities that are out there? Well, they look something like this. This isn't unusual. Although the stats are a little bit skewed to do with the platform, the actual vulnerabilities seem to be pretty standard with this. Cross-site scripting being the biggest cause of vulnerabilities out there, the biggest cause of reporting them. SQL injection used to be the one that was the biggest, although people are getting more and more in tune with what SQL injection means and why it's a bad thing and how they protect against this. So that slice of the pie is going down slowly. It's being replaced by cross-site scripting. Cross-site scripting will start to be addressed, and it's one of the big things that I'll talk about here. So that will get smaller. What do I think the next things are going to start becoming more of an issue? Things like authentication. Authentication takes a very tiny slice of the pie, mostly because the attackers or hackers or whatever you want to call them go for the most easy thing that they can do. And cross-site scripting is shooting fish in a barrel with a lot of applications. Authentication flaws and stuff like that might take a little bit more effort. So what they're going to do is they're going to look at them later. So over time, some of these portions will start going down a little bit more. And some of them will start to grow. So this is just a quick snapshot in time. So what the hell happened here? We were doing pretty well with addressing all the vulnerabilities in the network stack and now addressing vulnerabilities in operating systems and addressing vulnerabilities in applications. Why is web in such a bad state? The idea is we should get better each time. There should be less and less and less. What happened? Well, HTTP, which is also known as UFBP. Does anyone know what that acronym stands for? No one out there? Yeah, pretty much. The amount of stuff that's being transported over HTTP just because it bypasses proxies and bypasses firewalls and gets inside the net, gets inside the security, is just... So that's, in the security industry, sometimes we like to call HTTP the Universal Firewall Bypass Protocol. Because generally what happens is your application and your network and your internal assets are built like a fortress. All the sensitive information, everything is on the inside. It's in the keep. You try and make sure that it's all nice and secure. So you build nice, big, strong walls around it. And hopefully you guys have heard of, defense in depth. Well, what happens is you build more walls around it. And on this example, you build another wall again. And then you put a nice big ditch and fill it with water and you put guards on the tower. What does HTTP do in terms of the network nowadays? Well, it blows big holes in the wall so anyone can just walk straight past. And also, even though you might have guards on the walls that will shoot arrows at people that they don't want, that may be wearing the wrong colour jersey or something like that they're known enemies, wrapping stuff up in SSL basically encrypts it, and if it's encrypted to the source, the guards don't know what's coming through. They can't analyse it because it's encrypted. So this is one of the issues. Web apps are becoming more and more of a target because of where they are and because they're inside and they can bypass through a lot of the security controls. So let's have a quick look at some of what the security controls out there are for different things. So security controls for the network. We've got firewalls, as we said before. We've got intrusion detection devices, the guards standing on the towers, looking and saying, okay, is that a friend or a foe? Do we let them in or not? We've got vulnerability scanners that look for known issues, known configuration problems, patches, patch levels, and things like that. And we've got certain procedures to help harden network devices and network servers and things like that. We've also got VPNs to segregate traffic from different places and all that kind of stuff. In software, we've got access control lists, not only on files now, files of who can read things, but also on the actual code. We've got sandboxes that code run in, so that even if the code is not well behaved, it can't escape that sandbox and it can't do anything really bad. Also, we've got things of saying, okay, what kind of permissions is that code allowed to do? We're starting to get, reasonable ways of buffer overflow protection. Everybody knows about buffer overflows now. The amount of them that are out there are starting to go down. It's only probably taken us 30 years. Buffer overflows was known as a major problem, and there was a paper written about it in 1970. And so now we're starting to address it. So we've got some lead time on these things. We've got least privilege, so we know, not to run a web server as root and not to run, critical services as local system and things like that. And we've also got libraries and frameworks that are out there that have some level of quality that we know of. We know that, they've been reviewed to a particular level. We know that they're less vulnerable to things. So we use them more because reuse is good in software engineering, but also it gives us some control over security because the quality of the code is known. This is what we've got on networks and traditional software. What have we got on web software? Anyone? Yeah. It's not quite this bad. There are things out there, but there's nothing, that's the de facto standard of things. There's no, really well-known framework that everyone programs onto the web for, and SQL injection and cross-site scripting don't happen on that because it's known to go through particular functions that strip all these kind of things. So what's happened is we found out that the web's different. The web's different from networking and is different from traditional software. And what happened is, as we did the paradigm shift from the fat client model of everything sitting on your local machine and processing it there, to processing it going back actually going from the mini or the mainframe to the local machine and doing all the processing there and slowly moving stuff back again, some kind of amnesia set in. And we forgot all the things that we learnt before. So we underestimated the target that web servers would become. Web servers are a great target for attackers for a number of reasons. First of all is they're in this really odd position in the network topology. They're semi-trusted machines because you have to publish data to them and stuff like that, but you have to have anonymous users access them at the same time. So them two security things are against each other. Also, generally, web servers are very high-powered machines with a nice big fat network pipe. And if an attacker wants to use it for either a denial of service against something else or a worm, it's a great target. If they can get control over that, then they've got a much more powerful machine than they could possibly get any other ways. We also rushed into development, and we forgot a lot of the things that we learned from previous development. We've got perhaps this, the rapid prototyping and a year on the 7 months on the web is effectively a year in real life, and all them kind of great, let's push things forward. But we lost track of some of the things that we were doing previously in networks and in software, in the quality and the checking and stuff like that. So we forgot a lot of the lessons. We forgot a lot of the software engineering lessons. We also forgot that the web's different in that it's a different environment. There are different issues than there are. There's a lot less control that you have on how things operate in the web. There's different kind of attacks. Buffer overflow attacks on the web are very, very small in terms of by application percentages, by vulnerability percentages. So all of the things that we did learn were thrown out the window, and we didn't start to address the new things that were out there. Sometimes I wonder that we actually got as far as we did. We're just hanging on there by the fingernails, some people say. I don't think it's quite that bad, but it could be a hell of a lot better. So the web was never really designed to be secure. It was designed for geeks sharing physics documents. It was designed to be static, just information gathering. It wasn't ever designed to be a platform to run architectures off. It certainly wasn't designed for a platform to run a multi-billion-dollar business off of. So what kind of things are in there that are against security or security concerns with the actual design of the web, and things that we have to overcome? Well, one of the big ones, is that we intermix code and data all the time on the web. It's like having a signal channel and a control channel. If signals can start getting misinterpreted as control, then all of a sudden you can make free telephone calls if it's on a telco network. It's exactly the same that happens with buffer overflows. The stack is considered to be data, but there's code in there in return addresses, and if you can push enough data onto there that overwrites the return address and it becomes code that helps to control, then that's how you can overtake this. Exactly the same with the web. Having JavaScript embedded into HTML markup is the same kind of thing. We also have no control over the client. Because the web being so open, which is a good thing, means everyone can develop on it, it also means that anybody can write their own web app and can also, their own web client, and can also do commands directly to a web server using Telnet or Netcat or something like that. Anything that you set on the client, you can completely not trust that it will behave correctly. And that's one of the assumptions that people have. Another big problem with the web in terms of security is there's no state. You have to add state onto it. It doesn't come there as part of the web infrastructure. So if you take things like when someone authenticates against a system, you want to know who that person is, so then they can track what their permissions are every time they access a resource or something like that. You have to have that state of who that person is and what they're allowed to do. Follow them with them all the time. It's an extra thing you have to keep considering. And also, what we've done is a lot of these issues, the ones above that we've talked about, we've effectively patched them. We've added something on top that sort of addresses it, maybe not quite. So things like for state, we've added cookies. Cookies help us with state. Things like authentication, HTTP basic and HTTP digest for authentication and things like that. To stop data from being viewed and man-in-the-middle attacks, we've got SSL and stuff like that. They're all things that have been added on top of the web, on top of things. And one of the mantras that I like to do is you can't patch for security. You have to add it in at the very beginning. So we've got these technological problems. We've also got the educational problems and the learning problems. Is that the learning curve of writing stuff for the web isn't that steep, really. If you're doing more complicated stuff, then yeah, but anybody can publish a page or can put a shopping cart up online and things like that. So the writers of web apps are becoming, they're not what I would call the hardcore developers that were writing the applications previously. You have things like, pre-built shopping carts for mum and pop shopping stores, which they go and, they see a book and they go, oh, e-commerce for dummies. There's some stuff in there, there's some code in the back of that. I'll just copy it out, I'll put it onto my site, and everything must be just fine. And they wonder at the end of the month why they actually get a credit card bill, because someone's been messing around with their systems. Before I wrote the book, sometimes I was a little bit reluctant about writing stuff and getting it out, because you have the thing of, I know this stuff, so everybody else out there must know it as well. So I went to my local Barnes & Noble, and I went through some of the books that were on there to do with web programming, and I was pretty horrified that out of, can't remember how many I looked at, but there was something like 34 books that I went through that the code actually had security flaws in there. So as I went through and thought, oh, if someone's learning how to do something, then this code is teaching them how to do it, and it's teaching them how to do it wrong. And they have no idea. So you've got the writers, you've also got the attackers. And the attackers, the skill for attackers on web apps aren't nearly the same as the skills to attack, normal web apps, normal apps. If you've got things like a buffer overflow, actually crafting an exploit for a buffer overflow is pretty difficult. There's some serious hoops that you have to go through. To actually find a buffer overflow on some applications, you have to do, reverse engineering and really understand the underlying, the instructions that the processor executes and how things go from there. As we'll see on some of these, it's not difficult. Some of the attacks on web apps are not difficult at all. So what happens when you get hacked? Well, sometimes you don't know about it until it's too late. How many of you guys have heard of Card Systems? They were a credit card processing company. They were like, so say for instance, wasn't one of their clients, but say for instance, McDonald's uses credit cards, it goes to this place, it verifies the transactions, passes them on. They had their database stolen of all of their credit card numbers and people's data from that. Through an SQL injection vulnerability was the talk. Harvard Business School. Anyone heard of them being attacked? Harvard Business School has an online, like an application thing, where you put your application in, so that where you put, what your SAT scores and your essay and things like that, and it goes off and it gets reviewed and it comes back and it says, welcome, you've been accepted to Harvard Business School, or no, sorry, go to one of the other schools. What they found, one of the guys that was going through that found that he went to the application and he saw ID equals 1234. And he thought, so what do I change? What happens if I change that to 1235? All of a sudden, he was viewing someone else's application. The unfortunate part of that was, I believe, that application hadn't finished yet, hadn't finished going through all its processing, so it hadn't got an approval or a rejection, and so therefore, all of the comments were on that as well. And I hope that it wasn't saying, this applicant's a moron and shouldn't be. And so, one of my favourite ones is the Paris Hilton hack. Have you heard about that? There's a lot of how this happened or not. But anyway, Paris Hilton got her cell phone hacked, and a lot of pictures were released out onto the web, including some of her friends' phone numbers, who also had to go and change their phone numbers because they were getting harassed and something like that. How did it happen? Well, what happened was, one of the stories is that you've got, what happens if you forget your login? What happens if you forget your password? Well, you need some system to say, it is me, let me get back in and let me change your password. And so what a lot of them do is they say, what's the secret question? And a secret question was, anyone? What's your pet's name? And so with the marvels of you guys, so I blame you guys for having her system hacked. How did Paris Hilton get hacked? Well, she answered, what's her dog's name? And there we go. That was it. They were in. So it's all your fault. So that's what happens sometimes. Sometimes, though, it's just good old-fashioned graffiti. And I see that you guys are great fans of graffiti, so I think you might appreciate these. Recording Artists Industry of America. Looks exactly like their normal homepage. Apart from, piracy can be beneficial to the music industry. Adult entertainment, now I wonder where that links off to. Inside the RIA with Eric Cartman, and I doubt that he's a very good spokesman for the RIA. And my absolute favourite, where can I find information on giant monkeys? Another one. Doesn't look too bad. Until you notice that it's actually Al Jazeera's homepage. You'll see that these are starting getting less and less subtle. A lot less subtle. So let's have a look at, what is a security bug? Let's start off from the very, very beginning. So a security bug is a mixture of is a combination of three things. It's a combination of an asset, a vulnerability, and an attacker. If you guys back in high school when you were talking about, what is fire made out of? Fire is oxygen, heat, and a fuel source. If you want the fire to go out, you remove any side of the triangle and the fire goes out. Yeah? So if you've got these big, oil fires, Red Adair and his team comes along, what do? Do they spray water on it? No, because you're probably not going to get the temperature down enough to do anything different. What do? They set an explosive off next to the pipe, which sucks all the air out of it, and then you've just got a stream of oil that you have to be really careful around, but the fire's gone out. It's the same for a security bug. You've got an asset, a vulnerability, and an attacker. We start off looking at the assets. If there's no asset, then who cares whether there's a vulnerability or an attacker can get in there, because there's nothing for them to steal. Attackers, you can say that, attackers may not be, you can't get rid of them completely. But some companies like to say for a risk assessment point of view, that once we're inside of our firewall, there's no attackers. We'll forget for the moment that some stats say that 70% of attacks against the system come from the people inside the firewall. So, the lunatics are already in the asylum. Don't worry about the people on the outside because they're still doing enough damage. But some people say that based upon a risk assessment point of view, we'll trust all the people inside. And if your application is only accessible to inside, that side of the triangle's gone. We don't have to worry about it anymore. That's two sides we've managed to knock out. The third side, the vulnerabilities, is the difficult one. To make sure your software has no vulnerabilities whatsoever is a particularly difficult thing to do. So let's have a look at where security bugs hide. Now, a couple of you guys were saying, like the previous book that I did, and it'd be nice to take James's credit, but no, I didn't write the other book that went along with this series. It's either James or Hugh Thompson wrote it. But software is part of two things. It's part of how it's designed and how it's implemented. Be nice to think that these two circles overlap completely, in that how you design things and how your programmers write them are completely the same. And unfortunately, that's not the case. Functional bugs usually lie in this part of the diagram. What they are is they're things that you've designed, but the programmers haven't implemented them correctly. So they're things like, doing 2 + 2 = 5. The design was it was supposed to add things up correctly, but it didn't. Security bugs, on the other hand, are in this part of the diagram. What they are was the system was designed to do a particular thing. The programmers coded it to do that particular thing, but it does something extra as well. So let's say, for instance, we've got a media player. Media player is supposed to play encrypted content. What it might also do, though, is to help it with buffering and for performance, it might download the stuff and unencrypt it and store it in a temporary file and then play from the temporary file. According to the functionality, it works just fine. But there's this extra little side effect, that there's this temporary file which has all the unencrypted data in it. So this is where these kind of security bugs lie. So how do you look for them? Whereabouts do you look? Well, whereas with functional bugs can lie anywhere in the software. With security bugs, we've got some kind of head start in that, because of the triangle, they're only going to exist in certain places. So what Foundstone have done is they've created this security frame, consisting of configuration, authentication, authorization, user and session management, data validation, data protection, error exception handling, auditing, and logging. These are the kind of places where we found security bugs generally lie. Now, depending upon the type of software, you can generate a checklist to go through. And you can say, okay, so for instance, authentication, check that you can't do direct accesses. So, if I know the address of a page, what happens if I request that before I've authenticated? Yeah, so there's a series of checks that you can do with that. So it gives us a set of common bugs to look for by going through these kind of checklists. The thing is it's naive to believe that any kind of checklist is going to be comprehensive enough and cover all of the kind of things that your applications do. So you've got things that are application specific, that your application does that none others do out there. The way that it works is different and it doesn't fall into all of these standard canned tests. What happens if new attacks come out there that you haven't got a check for? Do you just say, well, I'm not worrying about any kind of vulnerabilities that were released 3 months ago. They don't exist as far as I'm concerned. You can't do that because your system's still vulnerable. So thinking about new tests and new things to do is actually pretty hard. It's like if you're an artist. I've got not one artistic bone in my body, but I'm told that artists, when they get this nice big blank canvas, can sit there and stare at it for ages. Of like, first of all, what am I going to draw on this? And second of all is once they've got a view, where do they start? Do they start in the upper left corner and work in? Or do they start in the middle and work out? Sometimes it's hard because you've got this nice blank canvas. Where do you start? There's such a big problem. Where do you start looking? Also, you've got the phrase, if all you have is a hammer. Have you heard that phrase before? If all you've got a hammer, what's the other part of that? All you see is nails. If you have a particular tool, then all you're going to see is bugs that that tool can address. If you've got a framework or some kind of checklist, and that checklist incorporates these kind of things, all you're going to see is bugs that that checklist finds. So you've got to widen things up a little bit more. So frameworks, like that framework that I showed you earlier, and mental models of how to look at software help. So have any of you guys heard of Stride before? Couple of people are more laughing at the Ministry of Silly Walks picture, aren't they? Yeah, well, I'm English. I've got to put a picture of some Monty Python sketch in there somewhere. So Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and come on, click, escalation of privilege. What these are mental models to help you think about bugs and how to look for new bugs. So what you do is you look at each of the functions of the application and you go through the security frame. So you go through your security frame of whatever your checklist is, and you look for the common bugs. Learn by your mistakes. Previous mistakes that you've had, if your application has been really vulnerable to cross-site scripting or SQL injection, look for them kind of bugs because you know that they're there. There's a professor at MIT called John Gutag who has a really nice quote on this, is bugs are a lot like cockroaches in your kitchen. If you have one, you probably have more, and it's not something that you should be happy about. So go through and look at the common ones that you find. But also go through Stride and think of potential attacks. So you go through and think, what can an attacker do if they could spoof a user? Yeah, what could they do if they could do that? Not necessarily how they could, because that comes with later with your test cases and your exploit. But what would happen if they could? Would they be able to access your application? Would they be able to do anything nasty? So let's go through a little example. We've got a particular bit of functionality. We'd sign up for a new account, for instance. We need to do authentication. So obviously there's our standard authentication checks in there. And then we go through the framework one at a time. Thankfully, you guys have got a great application which exhibits a lot of these things. The Gmail sign up. So we look at the spoofing first. When you sign up, could you spoof yourself as another user? Well, because you have to put your cell phone number in, and it puts that back, actually saying that you're someone that you're not, you've got some kind of identification of who that person is. Tampering with data, well, there's not much there, but you might want to try some SQL injection or stuff like that. Repudiation, what if someone signs up for an account and then says, it wasn't me? You've got their phone number. You've got some kind of method of saying, this person actually did go through that process. We did send an SMS message to tell them that they'd signed up. Information disclosure. So what would happen on here if people's telephone numbers got out? So think about them kind of tests. What about denial of service? Well, denial of service most people think about on the actual server itself, but you can also denial of service applications. One of the good ones with self-sign up is what happens if I write a script that would automatically just say, sign up user A, sign up user AA, sign up user AAA. Eventually what would happen is you'd run out of database space. And then no other users could. Or you go through the birth register or the census information and you sign up all of the cool names. No one wants to use your application because I don't really believe in logging in as Mike384972. I'll never remember it. So what on this it does is you have that sign up on another channel. So you have to do something and then you get a token back that then allows you to complete the sign up. So that two-factor helps. It stops it. Actually being able to try and script that is pretty difficult because you have to have that SMS delivered to a place where another script could pick it up and reuse it. And also you've got a phone number. And unless someone has unlimited phone numbers, I believe what happens is you're only allowed to sign up like 10 accounts on one phone number. So that helps mitigate it there. An escalation of privilege may not be an issue on this because everyone pretty much has exactly the same privileges as everyone else on sign up. You're only signing up for one type of account here. If you're signing up for different types of accounts, you know, a paid version where you had more space or more facilities, more functionality, stuff like that, it might be a little bit different. But this is like an example of how to walk through this kind of thing. When I was talking about information disclosure, it's mostly about not echoing back too much information. And one of the things that you guys are sometimes good at is error messages. Not only are they tell you what's going on, in that there's been a problem, they don't give away too much information, and it's nice to have at least, you know, some kind of bit of funny in there. Shouldn't all be serious of error 54 or something like that. So one of the things we've said earlier is rule number 1, you can't trust the client. So let me show you just a quick video. Of this is a great example of not trusting the client. We're at a company that sells software testing books. I did this particular presentation at one of the company's main conferences. So what I'm going to do is at the moment I'm storing that page locally, and then I'm going to go in and edit it. And you see there's a drop down saying how many of these I want to buy. So rather than buying 3, I'm going to say I'm going to buy -3. Now there's a restriction in there, and the restriction's from the user interface. Normal user would only be able to choose between 0 and 10 books. So what I'm doing is I'm changing that on the client. Now reload that page, and now instead of saying 3 books, I'm going to buy -3 books. And you see that, you know, $49.95 times by -3 gives me -149.85. I'm getting a credit back. Let's see whether this application actually does this. Now, all the while I'm doing this in the conference, the person who runs this site is having absolute kittens in the back of the room, saying Mike's attacking our website live and he's showing thousands of people how to rip us off. Well, before I've done this, and one of the things I'll say to you in just a bit is a lot of the examples that I'll show on the websites are already fixed, already recognized and stuff like that. Don't show any live exploits on these kind of things. So always give enough information so you can track these back. And great, there we go. Anyone worked in retail before? What happens if you put a negative value on a credit card charge? That gets put back onto the credit card. So I've now got $150 odd on my credit card. It even gave me tax back, but unfortunately I still have to pay for shipping. So I earned $4 out of that, so that's not too bad. And when actually talking to the guys when I told them about this vulnerability, they said that yes, that would have happened. You notice that 4111? That's a credit card number that does exist and gets verified and okay. But it's a credit card number that never ever gets billed against. So I didn't profit out of it at all. But what would have happened if it would have been a real credit card and it would have gone through, it would have printed out a little thing so the guys in the warehouse could go and pick the books up, and they would have gone to the shelf and they've gone, Mike wants the web testing handbook and he wants -3 of them. That can't be right. It's either got to be a printer malfunction or a software malfunction or a bit of spec. Or a speck of dirt or something on the paper. So he would have probably have picked the books up and shipped them to me anyway. So not only did I make $150, but I got the book shipped to me as well. So you can't trust the client, and that's using no tools whatsoever. That is just using the browser and Notepad. So you can't trust any of the stuff that the client does. How common is this? Well, it's pretty common. Let's just say that this is a major hotel in Las Vegas, and it's $109 a night. But in this case, my internet charge for using the internet in the room was -$10.95, so I got a little bit of a discount. The next day, actually, my internet cost -$109. So I effectively stayed there for free. And then what happened is some nice big guys in suits come and knocked on the door and said, Mr. Andrews, someone in security would like to see you. And traipse down there, and then they get told, yes, it's a security review, and it's good that you found this, but it means that one of our systems is vulnerable and we have to fix it. It's all over the place, this kind of thing. So obviously you guys want to have a look at some hacks for today, and we'll step through some of them. We're going to step through some of the most common ones. We're going to step through session hijacking, and we're going to step through page defacements. We're going to have a look at some other security assumptions that people have and how they lead to security bugs. And what I'm going to try and do is I'm going to try and illustrate some of these with previous vulnerabilities at Google as an example. And this isn't a case of trying to show you guys up or anything like that. It's a case of, if you know that there's cockroaches in your kitchen, you know to go and look at other ones. And also, don't be surprised that there are cockroaches in your kitchen, because there are in so many other companies as well. It's just a case of, if you know what you're looking for and you can see that you've had these kind of things, then you know what to look for next time, and you know how to fix them, and you know how to start to address them. So why no live exploits? Or why no live examples? Well, two things is, as this is being videoed, I don't want it going up online and someone going, that's how we hack Google, and we've got a video showing us how to. Somehow I don't think Harry would be very happy about that. The other thing is, security vulnerabilities on web apps get fixed very quickly, because you've got this nice instant service pack phenomenon. If there's a problem, either a security bug or even a functional bug on a web app, as soon as you find it and report it, the next time you visit the site when it's been fixed, you get the new code. So you can't actually create a snapshot of that to do the exploit again, because it's already fixed. It's one of the great things about doing stuff on the web. You've got a great advantage with that over traditional software. So anyway, let's start going through some of these. We look at session hijacking. Session hijacking comes about because of one of these security problems that we've talked about before, because there's no state on the web. So you have to add state onto that. And one of the ways of doing it is to give users session IDs when they go, and then that session ID tracks them around. And then you can associate that session ID with who that user is and what permissions they have and all them kind of things. So you can go through your checklist and you can think, what would happen if a user ID could be guessed? What happens if I can guess a user's session ID? What happens if a user's session ID can be stolen? And you think, well, what would happen in them circumstances? And the effect is pretty much the same. Someone else can masquerade as another user that's not them, because they have the same session ID, and the web app doesn't know any different. But there are different ways of attacking the problem. There are different types of vulnerabilities, and there are different ways of looking at them and how to fix them. So guessing session IDs is a case of entropy. It's a case of what the size is of the session ID and how random it is. Good session IDs always have a high entropy. They're long numbers that change very frequently and are very, very difficult to guess. So let's just quickly show you an example here. I'll have to put the mic down, so just give me a second. So here we go. This is a neat little web tool called Web Scarab. And what it does is it's got this nice little tab here called Session Analysis. And what you can do on here is you can say, okay, give me a HTTP method and somewhere to get it from. And the HTTP version. And what you do is you say test, and that does a quick test to see whether, oh, actually I need to go to, gets. Yeah, that's not going to help, is it? So no session IDs there, but I think if I go No. Let's go straight to the Google one. Test. And this basically shows me that there's probably at least one session identifier in there by analysing the result. And this one's in one of the cookies. So it's told me, okay, this one here. Now I could start to do an analysis on that, but actually there's quite a lot of other information in there that's not part of the session ID. So how do I get them out? So I know that this is part of the session ID, so I could start doing a bit of a regex to say, okay, so start with some number of characters, and then it goes ID, and then when ID equals, and then what I want to do is I want to pull out anything that's not a colon. So colon's the end, is the end thing, and there's going to be one or more of them, and I close that, and then I don't really care what comes after that. So I'm going to do a regular expression to try and match what the session ID value is. How many of these do I want? Well, I want 500 of them, and I hit fetch. And it looks like it's not doing anything. But in the background, and it's probably not doing anything. Why is that? That looks good. If all else fails, grab the example that you had earlier that worked. Yeah, ID was probably in capitals, so it didn't get it. So there we go. So what it's doing now is it's doing 500 requests and pulling that ID out. And it's doing a difference based upon ones it had before. And I don't know about you, but I look at them numbers, they look pretty random to me, but it's a lot easier if you look at the visualization of what's going on. And each dot is one of the values. And you can see that that's pretty random. If it's not random, you can start to see certain things. If you saw a line going up, which was what I was going to show on the flower shop one, what I'll do is after the talk I'll show you what they look like. But if you saw a line going up or a line going straight across, it's probably some kind of one that's based on sequence or probably one that's constant. So the fact that they're all over the place makes it look like it's pretty random. Sometimes you might see that they're in bands, which means that the algorithm favours certain values over others. Sometimes there might be big gaping holes in here. So, you know, it might be like there's a big hole in this area here. And that might be that based upon a particular time it favours certain values and things like that. So looking at cookie values over time, looking at any kind of session ID over time, helps us have an idea of what the entropy is. And so ensuring good entropy and ensuring a good address space for session IDs helps us protect against guessing what them values are and people masquerading as other users by that. So the address space is dependent upon the number of users that you had logged into your system at any particular time. So let's say we've got 128-bit session ID, about 16 ASCII characters, and what we can do is on a machine we can do about 10,000 guesses per second. We also have 100,000 users logged in. We've got a really popular application, lots of people are logged into it each time, so that reduces it. I only need to get one, by the way. How long is it going to take me? Anyone care to guess? Day? 2 days? Any longer than 2 days? A few days? Week? About 300 years. So having long session IDs and making sure that it's making sure that the entropy is good. If it's a case of it's not, if the entropy is not good and it's sequential, it's going to take me seconds to guess what the next one is. So actually, guessing session IDs, if you just take care of these few little things, it's much easier to either steal a session identifier or to fix one. And sometimes it's easier to fix one. So let's have a walkthrough of how to fix one. Let's say we're at a cyber cafe. We've got some shared machine that we're going to use. We're just going to log in and we're going to check our email, or actually we're going to check our bank account. Along comes our little hacker guy. The hacker guy goes to the bank account. The bank account homepage gives him his session cookie. So he retreats off and he has a think and says, okay, I'll remember that session cookie, what it was. Some unwitting person comes along later on, sees the machine, and goes to log in, goes to the bank account. What happens with cookies? They're automatically sent whenever you go to the next, whenever you visit that same site. Cookie's already set. Doesn't have to issue it again, so his cookie's the same. It's 1, 2, 3, 4. He gets the home page back. He provides his login details. He logs in, and he gets his account info back. What does our attacker guy do? Our attacker guy goes to a completely separate machine and fixes that cookie information. So he goes to the account page and provides the cookie ID, and as far as the application's aware, it thinks it's the same person because that cookie ID is the same as what the other person's using, and there's no state on the web. It doesn't know that two people are logged in and they're at two different pages. So they effectively get the account value back. So that's one way of doing it. Very easy, isn't it? So, protecting against the session ID guessing and protecting against fixing, ensure good session ID entropy, and always give people a new session ID when their role changes. When that other person logged in, if they were given a new cookie value based upon when they logged in, so they log in, they get a new cookie that tracks them through, that value that the attacker knows isn't useful anymore because it was only for a particular role that doesn't have any permissions. What would have had to happen was the user would have had to log in and then gone to grab a coffee or something, the attacker quickly sneak over. Generally, that's an attack that you can't protect from technologically. More common approach is to steal session IDs. There's two methods of doing this: stealing them in transit and stealing them from the browser. In transit, HTTP is a clear text protocol, so what do you do to protect stuff in transit? Stick it over SSL. Yeah? What happens if you get a box like this that comes up? What does this mean? It means that there's something wrong with the SSL connection, in that the certificate was issued to a different company that where you're actually heading. I promised my wife I wouldn't take the mick out of her on this one, but I'm going to break this right now. What do these two buttons mean to most people? This button means, no, I can't do what I was after. This button means, yes, I don't care, just let me get on with my activities. Yes, let me get on with my activities. Could be now suffering from a man in the middle. It could be that someone in the middle of that transaction is presenting another certificate and decrypting the SSL traffic between the two. You'll see it with tools like Paros and stuff like that. So make note of some of these warnings. Stealing them through the browser, let's go back, is that, so sensitive information over HTTP, protect it using SSL, make sure that the SSL configuration actually matches the box that it's on, and also make sure that it doesn't go in get parameters. Any kind of sensitive information like credit card information in get parameters are also logged on the browser. You can protect cookies with session ID in some ways by having the secure flag set. And what the secure flag does is make sure that cookie will only get transmitted over a secure connection, over SSL. Most pages get built with multiple requests. Not only the one request for the page, but also requests for the images and stuff like that, and JavaScript. Now, if the page itself is pulled over HTTP, great, the cookie's protected. But if images aren't secret, so why pull them over HTTP? If that's the case, then the cookie goes with it, and the cookie's unprotected for that moment, for that particular transaction. So this is mostly configuration issues. A more common way of stealing session IDs is to use cross-site scripting, which I'm sure you guys are aware of. So let's walk through a quick example. We've got this flower shop. We've got somewhere on the flower shop where we can leave messages for other people. Say, guest book, someone saying, what a great site. What happens is our little attacker comes along again and says, oh, this is a great place. I can leave things for other users to pick up. So what he does is he leaves this little thing here, leaves a JavaScript. Once we said before, code and data intermixed. Once that gets displayed, it's going to pop up a little message box. Now that might be annoying as hell, but it's not a security vulnerability because it's not attacking any kind of asset. What's one of the assets on here? One of the assets is your session ID. So what we do instead is we put an image in there. Now that image is a 1x1 transparent pixel. Users aren't going to be able to see it, aren't going to be able to notice it at all. But what that pixel does, when it goes and requests that, it also sends a parameter to the attacker's website with the cookie value, this document.cookie. So, when our Joe user comes along to visit the site and goes to the guest book, the code automatically runs. He goes there, the script starts executing, and the browser goes, oh, I need another image. Where do I get this image from? Well, I get this image from the evil attacker's site. But that image tells me I have to add that session ID parameter onto it, which it does. So he's got that, and then the image comes back on, and it looks no different to the user at all. But in the meantime, on the evilhacker.com, there's logging all of the session IDs into what's known as a cookie jar. And so at any point, the attacker can come along and pick out these, and they could be scrolling them in real time. They know what kind of session IDs are being used and start using them to hijack other people's information. Once again, how common is this? Pretty common. How easy is this to find? A 14-year-old found it a couple of months ago. The story was he was sending JavaScript to his friend. Now that's just, no. He'd learned about cross-site scripting from some kind of web page or some kind of book, and thought, what happens if I put alert in an email that I'm going to be sending to one of my friends? And this was in the subject header. Bang! Cross-site scripting error. Now, rather than just doing an alert message box, what he could have done is he could have stolen his friend's session identifier and reused that in his own request, and all of a sudden he's logged in as that person and can do all of the things that they needed to do. So how do you protect against this? Now, generally I can say this over and over again, and I'm asked sometimes with interviews of the book, what's the one thing that I recommend people to do? I recommend people to validate their inputs. Things like JavaScript and stuff like that has no business being in fields that are displayed to users or stuff like that. So validate the inputs that you're getting what you're expecting. Now in a header, you're expecting, alphabetic characters, numeric characters, maybe some punctuation. You're not expecting script tags. Also, validate application output. Just because it's in there, don't trust the data in the application is okay. Do this defense in depth. Validate on the way in and validate on the way out. The easiest way of doing this, and that would solve 80% of cross-site scripting problems and stuff like that, is really these tags here. This open tag and the close tag is what separates code from data. Markup is still code, so a bold tag or something like that, but also JavaScript tags. Change them. The user probably doesn't mean that they want this angle bracket. They probably mean that they want that bracket displayed. So change them from that to its HTML equivalent, which is &LT or &LST. So then it gets shown, and you don't cross that boundary between code and data. Don't just think that's the only way of doing it, though. So whitelist the kind of inputs that you want, the kind of things that you're expecting data to see. Because there are so many different ways of encoding these, it's ways of doing it. There's a lot of them. So be aware of these things. Also be aware of your protection of the actual session cookies themselves. Sharing session cookies between applications extends the attack surface, because there might not be a vulnerability in one application, but if there's a vulnerability in the other application which shares the same identifiers over a single sign-on, the other app becomes vulnerable at the same time, and you might not have any control over that at all. So you can restrict the session IDs in cookies and stuff like that by using the domain and path attributes. Say that this cookie for a session is only valid for this particular part of this application. It shouldn't be used and shouldn't be even considered to be part of an ID for another application. And that limits your attack surface. HTTP only in Internet Explorer provides some kind of a limited amount of benefit. What this tag is it's a non-standard tag. Just like with secure, but secure equals true, you basically just put HTTP only on the end of a tag. And what Internet Explorer does is it says this cookie here is only really for me to send to the server. Local code shouldn't have anything to do with this. And most session identifiers, local code don't have to have any knowledge of session IDs at all. It's really just to help the server keep track of who's where. So if there's a cross-site scripting vulnerability and your cookie that's holding that session ID has HTTP only on it, that JavaScript will basically return null because it's marked as that cookie shouldn't have any kind of access from local code. And it's one little word, and you might as well put it on there. Most people using Internet Explorer will get that benefit straight away. It's in as a bug feature request for the Mozilla code base. They think it's a great idea. Loathe Microsoft to have any great ideas, but they do occasionally. And it's been down there on about a year. Maybe they'll get around to adding it on at some point. So how do we do page defacements? That's one of the things that we were going to say. So we pretty much covered, session hijacking. What about page defacements? Well, cross-site scripting can be used just as easily for page defacements as it can for session hijacking. So cookies are just a small amount of information that you can get through the document object model going through JavaScript. JavaScript can not only gather stuff, but it can also change elements on a page. That's how dynamic menus and all them kind of things work. When we're talking about assets, an asset might be your ID, but your asset is also how your page looks. Because if you're a site that people trust, the information that's on your site is still an asset. People may do certain things based upon what your site says. So let's have a quick walkthrough of cross-site scripting page modification. We've got a website. It's a news website. People might believe that the stuff that they see on the news is exactly what's going on, so they might do certain actions based upon current news. Our attacker comes along and finds a cross-site scripting vulnerability, and he uploads an image. And he puts that on his evilhacker.com site. Along comes Joe User, and the attacker sends him an email message. Now, it might be a friend that's trying to trick the user into doing something. It might be some kind of spam message that goes out. But the email says, start dumping your Microsoft stock. Why? So, the user goes along and looks at a page, and instead of seeing the page that's supposed to be there, he sees a page that looks completely different. How'd that happen? Well, the email said something like this. The email is a link to the page, and he's found a particular vulnerable parameter. And instead of picking up a cookie or something like that, what they've done is they've said document.images.38. So the 38th image in that page, change it to the one that I've created rather than that one there. And it happens almost immediately. And they see that information rather than the one that's there. But if you saw that link, would you click on it? Some people shaking their head. Some people, well, not too sure. What happens if you saw a link like this? So you can obfuscate these things. You can hide them. This does exactly the same thing. TinyURL is a great thing for hackers to hide phishing links and stuff like that. Pretty common. This was found October 2004, 2005 by a guy called Jim Lay, who's got a great website, a great blog saying all sorts of things. Found exactly this vulnerability in the search engine homepage and managed to make it look like you go as a going subscription. You're not, are you? Because I'm going to sign up for this now if you are. $5, well worth it. And sent this out to some of his friends. I dread to think if anyone actually filled this out and sent him the credit card details. But it's pretty common. So one more for the road of cross-site scripting, and then we'll call it a day on this, and we'll start wrapping stuff up. Cross-site scripting can be used for actions. So you can do things like cross-site request forgeries, which embedding a particular action onto a page gets you information back. It's like a user clicking on something, but they didn't do it. It was the JavaScript that did it. So this piece of Ajax code, what it would do would be, there goes all my Gmail contacts. Put into maybe an image tag, which then gets sent off to someone else. It's all their emails and stuff like that. What about if I was buying a book? What happens if I was doing something like this? What happens if I had a script that said document.location equals this? Oh yeah, that looks like a good book to buy. If I managed to put this into a review, whenever someone went to review, bang, all of a sudden they're at this page, and they wondered how they got there. What if, hold on a sec. So I'm just using Firefox because Firefox has got some pretty cool plugins that I can use to sort of show what happens on these kind of things. What happens if this review there was a cross-site scripting vulnerability? Now I'm going to sort of just use the DOM inspector just to show the kind of thing that you could do on this. But there we go. There's the page. What would happen if instead of just the document.location equals, if I did take out that script, what would happen? It's basically saying document, some form, click the submit button. Oh look, book's in my shopping cart. Without the user having any control over what happened at all. Now I could probably change the quantity as well. Maybe some way of authors maybe boosting their sales or anything, and I wouldn't possibly dream of doing something like that. But you can see that cross-site scripting has so many different places that it could affect users. And it's hardly getting any recognition out there. SQL injection, most people are starting to understand what that is and why that's a bad thing. So now everyone's looking at cross-site scripting. And there's even more vulnerabilities out there of cross-site scripting than there is SQL injection. So start having a look at them kind of things. So other attack vectors that we could look at. So cross-site scripting is a temporary attack. Users actually have to participate in the attack to some degree. They have to visit a web page, or they have to click on a link that has a vulnerable parameter or something like that. And some people say, maybe they could be unobservant. If they have a page with a load of CGI parameters and some of them look decidedly dodgy, would they click on it anyway? But that's beside the point. Cross-site scripting is a temporary attack. It has to have some kind of user involvement. HTTP response splitting, on the other hand, is a new attack. It's only really been talked about recently in the first couple of months. We're probably pretty new in finding out what kind of vulnerabilities we can use with HTTP response splitting and what kind of attacks we've got. But HTTP response splitting is an interesting attack in that it's a one-shot attack. You do it once, but it can have multiple effects. It's like one of these gifts that keep on giving. You do it once and it keeps on giving stuff more and more and more. It can potentially affect more than one user. If one user suffered from the vulnerability, with HTTP response splitting, it might be that a user that didn't do anything wrong at all also suffers from that vulnerability as well. So let's do a quick walkthrough of it. Let's say we have a machine, which is the bottom one, the black one, and it's going up and doing requests to a web server. So a quick walkthrough of the HTTP that goes backwards and forwards. Get request goes up to the server then replies with a code, says yes, it's okay, send the stuff back down, including all the HTML. One of the possible ways of doing redirects is to send a parameter to say, okay, redirect me to a particular page. The web server replies with a 302 message, and it sets the location header to the place where you want to go to. What happens with the browser goes, 302, it's moved to this location, so the browser then does another request for that particular location, and the server sends the right thing back. Yeah, follow me so far? What happens if we attack this mechanism? What happens if we say, instead of it being a proper page, what happens if we start embedding characters in there that starts to affect what the response is? So on this, we can see that you have to encode these up, by the way. You know, /r/n, you have to actually encode them you have to URL encode them, otherwise they get changed. But what happens is, this request comes up, the response that comes back from that is actually two responses. The response, the real one from the server, which is the 302 moved temporarily and the location, and then where it says null is the location that we've asked for, and everything else after that is faked, stuff that we do. We're now creating our own HTTP response. That HTTP response is 200 OK, and here's a page for you. And that page might have a payload, it might have a cross-site scripting, it might be a completely different looking page than it was originally, and then that little ellipse at the bottom would be the leftovers. But the browser ignores it because of the end HTML tag. How do we use this as an attack? What we do is we do two requests from our machine very quickly, one after the other. They have to use sequential requests. So the first request does the exploit, and the second request requests a page normally. What's happening? We get back two responses from the first one, and we get back a third from the other one, but that's ignored because the browser's only expecting two requests to come back. So the other one to index.html just isn't, it's completely ignored, and we get these two coming back. The first one is this move temporarily, which is the null, which is what we've seen. The second one is the payload. So, what does this mean? This means that the first page, the first request, is associated with this. Nothing really. The index.html is associated with this. Now that's bad, because that's not the index.html page. That's the one that we faked up. And it means that if someone goes to that index.html page from the browser's cache, they get the payload. So we can affect not only the location, we can affect caching and things like that. Now I said, you know, it keeps on giving. As long as you don't refresh the cache, you keep on getting back the malicious page. How does it affect multiple users? Well, most people go through some kind of web proxy, some kind of web cache to speed things up. Anything that goes through the page and anything that comes back get cached by the web proxy. What happens if you have another machine over here that sends a request for index.html, and index.html has already been seen by the web cache? What does it give you back? It gives you back the payload page. So this is quite new. This has only really been discovered and starting to talk about in the last couple of months. So we'll see how this works. If you really do want to have a good understanding of how this works, and including, you know, all the mechanisms and stuff, this is a great paper. This is a great white paper to go and have a look at, and it gives you a lot of in-depth of how it works. How common? Starting to get common. Blogger suffered from this vulnerability earlier this year. So I would imagine that a lot of sites that do redirects based on 302s also suffer from this vulnerability, Because they trust the data that's given them. They trust that someone's going to give them the right page. But what is it? It's exactly the same protection measure as cross-site scripting. Validate the inputs. What this is in the location where it asks for a page, it's that carriage return line feed. Breaks the line, the next line down, the browser assumes that it's a HTTP header. When it's not, it's still a follow-on from the location. So validate the inputs and validate the application outputs. And you have to be extremely cautious of all the data that you put in HTTP headers, because if they're user controlled, they can affect everything. They can affect things from location, they can affect things to caching, they can affect cookies and all that kind of stuff. To start wrapping up, we'll have a look at a couple of security assumptions, and I'll open it for questions. Is that the web's got no standards at all. Everyone says that, there's RFCs on HTTP and all the way that things work, but there's not. One of the examples was everyone can play nice. Everyone, whenever they go to a page that doesn't exist, it will give them a 404 page. But it doesn't. So the site minder or the analytics or stuff like that suffered from a vulnerability where it asked for someone to to say, here's a page that exists on my site, and I'll use that as your as proof that you own that web server, because that page must only exist because you can put them there. However, not your fault, but other people's faults. If that wasn't on that, if that page didn't exist, certain sites, so for AOL for example, didn't do things properly. They didn't give back a 404. They gave back a 200 OK page with a page that said I couldn't find that, which breaks the standard. But it means that I could register myself as a user of the AOL site statistics. Now, not much information in there, but if I was a competitor, I can see what kind of things people are searching on to get to that page. Other assumptions. Trust the data that's given to you. Google News does this. Grabs data from PR news feeds. And so many people have, Google News alerts of anything that has the title in there. Someone made a press release and said that Google hires a 15-year-old. And all of a sudden it's on Dig's homepage because they trusted the data that comes through there. They should only be trusted from known authoritative sources. Don't feel bad about this, because it gets a lot worse. North Carolina News 13 had a web page that had closing tickers for schools and businesses and things like that. What happened was they put up a page that said, our school's closed today because of boiler malfunction and it'll be closed, or such and such a business won't open until 10:15 or 10:30 because of weather or something like that. So the idea was there was a particular flow. You used to submit information, you used to get human approval for that information, you used to allow the companies to do any kind of changes, to update the time or something like that, and then it was published out to the TV. Our little hackers come along and just go straight to the allow changes, which what does that do? Propagates it straight out to the TV. Now, a bunch of students from North Carolina University managed to figure this out, and this link here is the chat page of them absolutely laughing away as they put things up on the screen. Anyone want to have a look at what they put up? Yeah, some people do. Here's a good one for all you hackers out there. And of course, one of my favourites. So they took it down after that and thought it was mostly unamusing. So we can filter out for bad input. I'm going to skip through these. And we're going to look at why all the problems. So why all the problems? Web servers are a great target. Web servers are a great target for all the things we've talked about before. And also, as you've seen, these attacks are not rocket science. They're dead easy to do. Most of the entry for skilled people are low, and the rush to innovate is out there. Get these applications out before someone else comes out. It's like the gold rush. I'm going to stake my claim to this part of the river, because if I'm not there, someone else will. And it doesn't matter whether the code's bad or not. The thing is some of these security vulnerabilities can kill a company. We've had loads and loads of companies that, because of particular security and because of security breaches and stuff like that, have suffered from not only PR problems, but also financial problems. Companies have been shut down for this. An example with Guess Jeans got fined a few years ago for having SQL injection on there, and someone found it, and the FTC fined them because they were releasing customers' information. Also, funny enough, is a drop in share price. One of the professors from Maryland University tracked share price against when vulnerabilities were released in a company, and he found that on certain vulnerabilities the share price dropped by 5%, which can affect quite a lot. Main reason why they're there is education, and nice picture of one of my colleagues, is people aren't told about security. They're taught about algorithms, they're taught about bubble sort, and they're taught about quick sort, and they're told about linked lists and doubly linked lists and all them kind of good things, and they're not told about validating for input and why it's a bad and why not validating for input is a bad idea. And unless you start to push it back to there, people are going to come out and they're going to still start creating the same problems. So if we want to go back and start fixing it somewhere, we start fixing it at education by telling people what they are. We start fixing it by companies being responsible and doing the right thing, training the developers up, making sure the code's clean, by doing them kind of things. So next wave of things coming up. How are we doing for time, by the way? Am I overrunning or is it okay? So the next wave of things that are going to come along is buffer overflows and DOS. We look at web services, they're going to be done in things like recursive payloads and stuff like that. It's all going to come back again. SQL injection, web services is going to be XPath injection. It's going to start coming back again. Cross-site scripting, same vulnerability in web service, external entity attacks, including other pages from somewhere else. Parameter tampering is going to stay parameter tampering. There's going to be nothing different there. It's going to be a different arena. XML actually helps attackers with payloads because it's a standard format. They don't have to worry about doing it specifically for an application. It's the standard. So just because we start to solve all these things with cross-site scripting doesn't mean they're all going to go away. The next technology that's going to come along is going to have exactly the same thing. So even though I've shown you a couple of examples here and I've shown you the vulnerabilities and how to look for them, be aware of how these kind of attacks affect the next wave of software that you're going to develop. Ajax is coming along and is being more and more used, which means more and more code pushed to the client, which means less control and less validation at the server. So we've seen what happens when you trust the client, and just because it's Ajax rather than Forms or instead of JavaScript doesn't mean that we should trust it anymore. Web-based worms. Web-based worms have already been done to some degree. They've had limited impact, and you guys have brought up things of pages that says we've noticed a lot of requests for a particular thing, so blocking it from there. We've got stuff like web-based keyloggers and backdoors, like back orifice, but for the web, is the next holy grail for web software. And as web software becomes the next platform for developing applications and things like that, that's what the attackers are trying to look at. That's what the hackers are gunning for their next big goal. Bidirectional communication to arbitrary domains with no refresh and preserved between sessions. In some cases, they're getting close. Some of it is already done. XSS proxy is a bunch of scripts that's already written for cross-site scripting in a frame that you can actually send commands to another machine once it's activated. Doing it over sessions, HTTP response splitting manages to preserve that between sessions in some way. So web app worms and viruses might be the next phase. Applications and operating systems have suffered from it. There's no reason why we can't expect the same in the future. There's a guy at SPI Dynamics called Billy Hoffman that's done a great paper on this, a great presentation. One of the reasons I wanted to go Black Hat is he's saying that he's possibly going to talk about it more at Black Hat 2006. So we'll see there. So lessons we've learned so far is it's not rocket science. As you see, you don't need any hardcore hacking skills to be able to do this kind of stuff. It's mostly common knowledge once you know the knowledge that's out there. There's so many more attacks. I wish I had time to talk all over them, but as you probably see already, I've well overstepped my time schedule. But hopefully you've all got the book, and hopefully we can hang around later and talk about these kind of things. So if I have to give you 2 things to walk away from, validate input and validate output. If you can solve them, 80-90% of the vulnerabilities that are out there in the web just go away. So watch for new attack vectors and institute some kind of security attitude. You'll never be able to design perfect web software. Any kind of software, there'll always be vulnerabilities in it all the time. You'll never be able to find every single vulnerability. But by doing things of awareness, of a security frame that you walk through and check stuff off, be able to think about new attacks and stuff like that, to actually think about it in that way, helps you. And also have some kind of security champion in your team. Have someone that has in their spare time, or one of their responsibilities, to keep up to date with security stuff. That if someone goes, you know, this little thing here looks a bit fishy, but I don't know whether it's really an exploit or or a vulnerability or how to impact it, that person's there that can go, yeah, it is, no, it isn't, and things like that.